Hello everyone and welcome back to our channel where we always look at educational content that help you improve in class and as a person in total. Now we are looking at the topics in the SS1 physics curriculum, and this is the fourth topic in that curriculum, and the topic is motion. Now motion itself in physics is a very broad topic, and it is divided into different aspects of it. Now this particular one is going to be focusing on the meaning of motion. We'll also look at the types of motion, and then we'll look at what is known as relative motion. So those are the aspects you're going to be looking at in this topic. Other aspects are distributed across your journey in physics. There are some you do here at SS1. There are still some you do when you get to SS2 and so on. So to be able to look at this, these are the breakdown, the number of subtopics we have to look at to understand motion, at least this aspect of it, very well. Now, we have to look at the definition of motion. That is, you're expected to be able to define what motion is in a way that is understandable, be able to define motion. Now, secondly, you should be able to classify motion into different types. Now, there are two major classes of motion. You can first classify it based on how the object moves. Now, that gives you different types of motion, such as the translational motion, the rotational motion, the oscillatory motion, and random motion. You see these four types of motion here, they are in one class, which is the way the object moves, how the object moves, okay? And then you can also classify motion based on time. So if you're looking at motion as it relates with time, you can then have types of motion such as uniform motion or non-uniform motion. Now, what we are doing here is we're going to be able to explain each of these types of motion and then give you practical examples of them so that you can fully grasp the types of motion that we have. And then after that, we'll look at the meaning of relative motion. You would have heard that term a number of times before now. So we'll be able to define it and then give you practical examples of relative motion. And then to end the topic, we'll solve what problems on motion and relative motion. So there are a number of questions we'll look at, and then we'll explain the answers to those questions so that you get it without any doubt in you. And please don't forget to subscribe to the channel if you have not done so already. On this channel, we give you educational content that improve you daily. So please ensure that you click the subscription button. It's just going to take a moment of your time. Hit the subscribe button, and you can also hit the notification bell icon so that every time we put out a new content, you will be notified. And we ask you to please help us by sharing this content on your page. Ensure that you share it so that others who need helpful educational content like this would be able to access it. We are here for you all the time. Ensure that you do so. And if you have any question at all, we are ready to answer all of your questions. So please just put it in the comment section and we'll definitely attend to all of your questions. So now let's dive into motion, at least this aspect of it, where we look at the meaning of motion, the types of motion, and then relative motion. Now let us look at the definition of motion. Now, you recall from the video on topic 3 where we looked at position, distance, and displacement. I did mention that distance and motion are intertwined. That is, they relate with each other, okay? And I did give us a recap of what we know as motion from our junior secondary school days. But now we want to define motion as it is seen in physics, okay? So when an object is at a position, you recall the definition for position as being the distance or the length of space between a point where an object is to a reference location, right? So when you place an object at a point and then it's able to move from that point to another point, now the way by which it moves or how it moves with time tells you what we know as motion. Now let me recap that so that you get it. So when an object is in a said location and then is able to change the position where it is to another position, what that object has done is that it has moved from point 1 to point 2. So it has undergone what is known as motion. Now, to define this in physics, we will say motion is defined as the way an object moves from one point to another. Okay, or we say the change in the position of an object from a reference point over time. Now, that's a more acceptable definition for motion. So let's put it down. Motion is defined as the change in the position of an object from a reference point over time. Okay, like for example, if you put a cup of coffee at a point on your table, and then after some time you discover that you can't find that cup where you placed it, there's only one thing that explains how that cup has been able to change its position, and that is by motion. That is, there must be an agent of force that has caused that cup to move from where it is to a new position. And this applies to us as well, because this is something that we do daily. We keep moving from one point to another. You move to your school, from school back home, even when you are in the gym having an exercise. All of these involve motion, because you are changing your position regularly, right, with time from one point to another with reference to another point. And this is how we define motion. Okay, so to recap it, we say motion is defined as the change in the position of an object from a reference point over time. Now let us look at the types of motion. Now, you understand that motion refers to how an object changes from one point to another. That is, change in position of an object with reference to a fixed point. Okay, so now the way an object can do this are very diverse. First, we'll be looking at the types of motion based on how the object moves. So let's note that here, based on how the object moves. Okay, now in this category, or in this class of types of motion, we have 4 different types there. We have what is known as the translational motion, the rotational motion, the oscillatory motion, and random motion. So we'll start with the first one, that is translational motion. Now, another name for translational motion is linear motion. And as the word linear means, many people often take it to be a type of motion that is done in a straight line. Okay, they just say that a straight line motion, but it is not always just a straight line. Okay, so but let's define what translational motion is. So to understand translational motion, I'll use this pen I'm holding now to explain. Now, if this pen were to move from this point where I'm holding it along this path, okay, and then stops at this point, what are you going to observe? First, you see every point on the pen, like the cap, the midpoint, the base, they all go through the same pathway, right? Straight like this. All points follow the same path. This is an example of translational or linear motion. Now, it is not restricted to just a straight path, in the sense that if I were to throw the same pen, now it would go via this curved path like this and then land here. Now, this kind of motion is a parabola, right? So you see that all points on the object like this follow this curved path as they go this way until they get to where they stop like this. Okay, so the way you can identify a linear motion is not whether it is going in a straight line, but that every point on the object follow the same path. If that is true, then that type of motion is a translational motion. Let's put that in writing. This is when all points on an object follows the same path. Okay, so this is how you would define translational motion. Okay, take for example a person walking from his home to school. Now, when you're going to school, do you follow a straight path? It's relative. Some go via a straight path from their house to their school, but some will have to navigate some turns as they go to school. But what you observe is that every point on their body follows the same path as they do this. Okay, so when all points are following that path and it's a straight path in the end, what you have there is translational motion. This is how we define translational motion. So examples would be a person moving from his home to school, a car driving from one location to the other. Say for example, a car driving from a city to another, moving from, say for example, Lagos to Abuja. That is an example of translational motion. A stone that is thrown at a bird on a tree, also observe translational motion. All of those are examples of translational motion. So please drop an example of translational motion in the comment section. Give us at least 5 in the comment section. Let us consider another type of motion still based on how the objects move. Now we have looked at translational motion. Now let's look at what is known as rotational motion. So when you look at rotational motion, okay, one thing you have to put in mind here is this. Now we often say this is when an object spins about an axis, okay, but I would prefer to define it from how all points on the body moves, okay. So when you say rotational motion, you get examples such as the earth when it spins about its axis. You could also have the same thing for when you spin a ball on your finger, a trick that many basketballers love to do when they spin the ball on their finger. There are other things that also rotate about an axis like that. But how can we recognize rotational motion, or better put, how can we define rotational motion? Okay, so you see, when an object is rotating, okay, take this ball for example, and then we make it spin like this. All points on the ball like this, what do? They move about like this, all of them rotating like that. Okay, now what do you observe here? All points on the object are moving along different paths like this, but they create something that we know as concentric circles. Now a concentric circles refer to circles that have the same center point. Okay, so that is, that object has the same central axis, and all points on that object are moving around that central axis. Okay, all points are moving around the central axis, and that is how you define rotary motion. So let's put this down. This is a motion where the object spins about an axis. In rotary motion, all points on the object moves around the central point to create paths that form concentric circles. Okay, so with this definition, you can easily identify what rotary motion is. When an object is spinning about an axis in such a way that all the points on the object move around that central point, okay, and they create a path that is known that forms what we know as concentric circles. That is, you see this circular path that go around the central point. Just like in the case when you spin the ball, your finger there at that point is forming the axis that it is rotating on, and you see all points form a concentric circle around your finger. The same thing happens when you spin what we know as a spinning top amongst other objects that undergo rotational motion. Please drop in the comment section at least 5 objects you know that undergo rotational motion. Let us consider another type of motion based on how the object moves, and this one is known as the oscillatory or vibrational motion. Oscillatory, vibrational motion. Now, here's the thing. When looking at oscillatory or vibrational motion and you try to define it, it looks a bit like what you know as translational motion. Remember from translational motion, I said all the points on the object are moving along the same path. Okay? So in oscillatory motion, the same thing happens. All the points on the object are moving along the same path. But there is a difference between oscillatory and translational motion. Now, the difference is that you see this time, the motion is repetitive in nature. That is, it continues. It goes to and fro. Continues like that, to and fro, along the same path. So it moves, gets to that point, and goes back the same path until it gets to a start point, and then continues like that to and fro. You see this kind of motion I'm just doing right now? This is an oscillatory motion. The same thing that happens when you pace about the room. When you move, and then you turn about and go again, get to where you started, turn about, and the motion continues like that. You see, that repetitive type of motion is called oscillatory. So even though all the points on the object are moving along the same path, it is not translational because it is repetitive in nature. So this one is called oscillatory or vibrational motion. Let's put this in writing. This is a type of motion where the object moves to and fro regularly, returning to its starting point. Okay, so you see here now, the object is moving to and fro and is always returning regularly to its start position. Now, when we say this, oftentimes we think that it's only looking at a type of pendulum kind of motion, but it is not that alone. You see, circular motion can also be known as the oscillatory motion. Take, for example, look at this pen in my hand now. If I wave it along a circular path like this, can you see this? This is the start point. Is regularly returning to the start point and moving to and fro. So even though it's not swinging like so, it is also observing oscillatory motion because it satisfies the definition for oscillatory motion. So don't limit oscillatory motion to just that kind of pendulum kind of action. It can also be circular motion. So you see, when describing circular motion, you are describing an oscillatory or a vibrational motion as well. So with what I've said, you've seen some examples like that, such as a swing set will undergo oscillatory motion. A pendulum will undergo oscillatory motion. Now, I want you to please drop in the comment section at least 5 objects you know that undergo oscillatory motion as well. Let's consider another type of motion, still looking at how the object moves. So far we have looked at translational, we have looked at rotational, we have looked at oscillatory. And I didn't mention that on this category or in this class of types of motion, we have 4. So the 4th one is the random motion. Now, when we say an object is undergoing random motion, another name for that is like when the object is going on an unpredictable path, okay, or the object is moving haphazardly. It's moving without an orientation as to where it is going next. So it's a very irregular pattern of motion. It's very unpredictable, very haphazard in nature. So to define this, we say it's a type of motion where the object is moving about or along an irregular path, okay, or an haphazard pattern, moving an haphazard pattern. That is what we call a random motion. So let's put that down. This is when an object moves along an irregular or unpredictable path. Okay, so it's moving haphazardly. This is random motion. Now, random motion is often called the Brownian motion after scientist Robert Brown. Okay, so let's note that here. That is, you can call it Brownian motion. So it is named this after scientist Robert Brown because he observed this that when he was trying to observe tiny pollen particles. Now, pollen are those tiny particles you find on flower. It's actually the male gamete of flowering plants. Okay, that's the part that fuses with the ovum to produce the fruit and seed of a plant. Okay, so while he was trying to observe it, he suspended them on water and then was observing with a microscope. Now, what he saw was that those tiny pollen began to move about the surface of that water. And even though the water appeared calm, as if it wasn't moving, the pollen kept moving about. And that was what led to the conclusion that water consists of tiny particles that are always moving at an irregular pattern. So they keep knocking each other as they move along that irregular path. And as they do so, they also knock the pollen and causes it to move. So you see, irregular movement causes the same pollen to move about irregular paths. So he then called that type of motion the Brownian motion. So in case you find question where you are asked to describe Brownian motion, know that you are also looking at random motion. Now, we see this always, say for example, if you observe smoke particles suspended in air, the smoke tends to rise and move along irregular paths, okay? And this is an example of Brownian motion in nature. Another will be the movement of dust particles suspended in air. So please drop in the comment section any other example of the random or Brownian motion that you know. Now, when considering the types of motion, we have looked at one classification which is based on how the objects move. Now, let us look at how the object moves with time. So types of motion based on time. Now, there are two different types of motion based on time. We have what is known as the uniform motion, and then we have what is known as the non-uniform motion. Okay, so let's start with the first one, uniform motion. So to explain uniform motion here, you see, when an object is moving along a path in such a way that the speed remains the same, okay, it doesn't change speed, it maintains the same speed along that straight path. Now, this is possible when the object is moving along a straight path, okay? So if the object moves along that straight path and maintains the same speed throughout the motion, that type of motion is called a uniform motion. Say for example, when a car is moving along the express at top speed, it is going to maintain that speed as it keeps going, as long as there's no obstacle and there's no problem. It can maintain that speed. Then at that point, the car is observing uniform motion. Or the same kind of motion you go through when you are walking a particular distance. If you maintain the same speed and you keep moving at the same interval of time, then that is a uniform motion. So let's put this down. This is a type of motion, okay, where the object moves along a straight path without changing its speed. Okay, so in this type of motion, the object has to be going along a straight path and the speed has to remain constant. That is uniform motion. Now, the second type of motion based on time, so this is number one. Number two would then be non-uniform. Non-uniform motion. Okay, in this case, the direction, the speed, or both changes with time. So, and this is what we experience almost all the time. So if you're walking a particular distance, as you are changing your direction, it causes you to slow down a bit. Okay, and then once you turn completely, you can then gain your speed back. So you see, you are slowing down speed, increasing speed, changing direction, amongst other things like that. And the same thing happens when you travel also with a car, or when you fly a plane, amongst other things like that. They keep speed at some point, but they change it, whether when they are moving, turning a particular corner, like in the case of a plane now. When it's trying to take off, it maintains the speed along the runway, increases the speed rapidly until it takes off. Now, when it is in space, once it is in the sky rather, it then maintains the speed as it continues along the path. But at some point when it's about to descend, it will have to slow down, come down, and then gain speed again as it's going down the runway. Then comes to a final stop. You see there that speed changes, direction also changes. The same thing applies when you walk, the same thing applies when you drive, amongst other type of motion that you undergo. We often go through this non-uniform motion. So let's put the definition down in writing. So this is a type of motion where the speed or the direction or both of an object changes with time. Now, this is how you define uniform and non-uniform motion. So let's recap. Uniform motion is a type of motion where the object moves along a straight path without changing its speed. And then non-uniform motion is a type of motion where the speed or the distance, or both the speed and the distance of or speed and direction, of the object changes with time. So they depend on speed and direction. So when the speed and direction remain constant, that is uniform. When the speed and direction changes with time, that is non-uniform motion. If you have any question on this, please drop it in the comment section and we'll definitely attend to all your questions. Please don't forget to like, share, and subscribe. Now let us look at what relative motion is. Now if you're following the video so far, we've been looking at motion. We've been able to define motion, describe types of motion, and now we are looking at relative motion. Please keep in mind that here on this channel we give you helpful educational content across different subjects. So if you have any challenge with the subject you're studying in school, be it maths or English or physics in this case, you can find videos that will help you on our channel. Now we are looking at the topics that are treated in first term of SS1 physics, and this is motion. We've looked at the meaning of motion, the types of motion, giving examples of such, and now we are looking at relative motion. So please ensure that you are subscribed to the channel. If you have not done so, you can subscribe by clicking the subscription button. It's absolutely free, and by doing so, you also get access to the helpful content that we drop on this channel. And you can also click the notification bell icon so that every time we upload a new content, you will be notified. And we are also asking you to please help us to reach many more students who need helpful videos like this. And you can do that by just simply sharing the video. It costs you nothing at all. You just have to click the share button, and then those on your timeline can also see this video and get access to it. This way we'll be able to ensure that this helpful content reach as many students that really do need it. So please help us to share the content. And if you have any question at all, whether it's on what we are doing or it's on something else entirely that is of course on your academics, please ensure that you drop it in the comment section. Drop the questions and be sure that we'll attend to all of your questions, all of your comments and reservations on the channel. We'll definitely attend to all of it. Thank you so much. Now let us define what relative motion is. Okay, so as the word relative means, that is, you're looking at it from a different lens. Okay, so when one object is moving and the way it is moving is observed by another object. Now that other object can be stationary, it can be moving in the same direction or in the same manner as the first object, or moving in a different direction and the same manner as the object. So all of these tends to change the way that object perceives the motion of the other. Okay, take for example, if you were in a race and then the umpire calls on your marks, set, and then he shoots, go. As you begin to run, all of you are running towards the same end, right? But as you do so, you begin to see some moving faster and ahead of you, while some will be behind you. Okay, as you observe this, there's a different thing that you see as a runner participating in that race, and it is different from what someone who is on the stands observing the race. The same thing happens when you're observing car racing each other. Take for example, you are at the Monaco Grand Prix and you're watching the Formula 1 cars move along their track. Now, to those who are just observing from the stands, they see these cars moving at a mighty high speed. They keep going round at a very high speed. But what do you think those who are actually driving those cars observe? To them, the person right ahead of them is not moving so far away from them. Because by the time the car goes past you, you see it move so fast and before you know it's out of sight. But to the driver behind him, he can still see the car and they still go over a long distance seeing each other. This is because both of them are moving at a very high speed. If the speed of the other driver behind should have reduced, with time you see that the other car in front of him will be out of his sight as well. But it happens at a time later than what you, the observer at the stands, observe. So what you are seeing here is relative motion. So you see it depends on the observer. Okay, so if we want to define relative motion, we will say this is the motion of an object as it is observed relative to another object, or just say the motion of an object relative to a reference point. That is how you define relative motion. So let's put it down. Relative motion is defined as the motion of an object with reference to another object. So it's important that you note that this other object could be stationary, it could be moving along the same path with the object, or moving away from the object, and all of these affects the way it sees the other object. And this can also be observed like when you are in a bus. If you are in a bus, the bus is moving forward. Now, when you are in a bus moving forward and you stand up from your seat and move towards the driver, okay, your own speed relative to the bus is different from that of the bus relative to the ground, okay? And the same thing happens when you are moving backwards, and also to someone who is just standing observing the bus pass by. You observe different type of motion. You observe the speed of the bus as it goes past it, and it sees you also moving in the same bus. So you see different type of motion relative to the same reference point. So it matters whether the object observing is stationary, is in the same direction, or in opposite direction. But to recap the definition of relative motion, we say it is defined as the motion of an object with reference to another object. Now let's answer some questions that are on types of motion and relative motion. Now this question here is from the UTME 1980 set of questions, and this says the motion of the moving skin of a talking drum can rightly be described as. Now they give you options which I've omitted in this question, but let us consider the motion that the moving skin performs. Now as you strike a talking drum, now what you observe is that the skin begins to vibrate. Now many may consider this to look a bit random in nature, but it isn't. It is actually periodic in nature because it bounces and moves to and fro to produce the sound that you hear. So that type of motion is either oscillatory or vibrational. They mean the same thing. Now the reason why I've just done this is because now when providing option, you might find oscillatory as part of the options, or you find vibrational as part of the options. So both of them describes the motion of the moving skin of a talking. This question is extracted from the 1985 UTME physics question, and it says which of the following types of motion are oscillatory, and then it goes on to give us about 4 different motions. So here's the first one. A diving board when it is used by a diver. Now if you've watched the Olympics, you often see divers go to the edge of their diving board and then bounce about at least 3 to 4 times before diving into the pool. Now while they do this, as they bounce on the board will then go down and oscillate back upward, giving you that kind of vibrational motion. So that tells you that the board is going through the oscillatory motion. So this is oscillatory. So not only are we going to identify the oscillatory motion, we'll also find the ones that aren't oscillatory and name the motion that they undergo. Now the first one here is oscillatory. Now the second one says the motion of the balance wheel of a wristwatch. Now the balance wheel of a wristwatch is one of the parts of a wristwatch that actually helps it to keep time, and the way it moves is it goes about to and fro, the way a pendulum would go. Okay, so that means that kind of motion, because you see it is to and fro and it's always returning regularly to its start point. So that is also oscillatory. So this is oscillatory as well. Now the third one says the motion of the turntable of a record player. Now, on a record player, you place your record, drop the pin on it, and then hit play. Now, when you do that, what happens is that it begins to spin. As it does so, the needle touches the record and then it produces the sound. Okay, but what we are concerned about now is the motion of that turntable itself. So it causes the record to spin about. So, and at that point, you see that every point on that turntable will go about a path that forms concentric circle. And that reminds us of the rotational motion. So this is not oscillatory, but this is rotational. Okay, and then the final one here is the motion of the center of a coin as it rolls down an inclined plane. So if you have an inclined plane like this, and then there's a coin at the top here, and it's rolling down. As it rolls, it is rotating down, but we are looking at the center point here. By the time it gets to this point, the center point would have just gone this straight path like this. And since we are only concerned about the center keyword there of the coin, the motion that center is undergoing is moving from one point to another along a straight path, and that is translational or linear. So that means this is translational. Now, since the question itself says we should identify the ones that are oscillatory, then our answer would be I and I only. And that's the solution to this question. Here is another question still on motion, types of motion, and relative motion. Now, this one says, a boy sits in a train moving with uniform speed on a straight track. Now, if his outstretched palm gently tosses his coin upwards, the coin will fall. Now, we have options such as in front of his palm, behind his palm, beside his palm, into his palm. So what this means is that he's seated in a train, then he stretches forth his palm. Now, let's assume this to be the coin, and then he tosses it gently, right? Now, you're asking, will the coin fall in front of his palm? Will it fall behind his palm? Will it fall beside his palm or into his palm? Now, to answer this question, the key word we need to put in mind here is that the train is moving with uniform speed, which means there's no inertia. Okay? And according to Newton's law, first law of motion, which is the law of inertia, it's supposed to continue with the same speed provided no external force is acting on it. So since no external force is going to be acting on the coin, it should go up and return back into his palm. That will make the answer to this question into his palm, which is option D. However, if you are to come across a question where you are now told that the train is accelerating, when there is acceleration, as long as that coin is in contact with the train, it will continue to move with the same speed as the train. But the moment it tosses it up, now it is not in contact with the train anymore. So the boy, along with the train, will be accelerated forward while the coin remains, just goes vertically up and returns down. So by the time the coin will drop, the boy would have moved from that point, which means the coin will be dropping behind his palm. It's just kind of like what you see when you watch some cartoons sometimes. You see a character wanting to run at a high speed and then it gathers momentum, and by the time he's gathering the momentum, something like the heart may move away from his head, and then by the time he speeds up, you see that the heart is still behind, and then they stretch out their hand and pick the heart. You know that funny thing you see in cartoons? That is what happens when an object is accelerating. Anything that goes up will just go up and back down because it's not in contact with the accelerating body. But in this case, the object is moving with uniform speed. So that means the coin is going to return back into his palm. Now, if you have any other question on this topic, be it on the types of motion, be it on relative motion, I will encourage you to please put it in the comment section and we'll definitely attend to all of your questions. And please don't forget to like the video and also share it amongst your friends so that they can also have access to this helpful content that we are creating. And please ensure that you are subscribed to the channel by clicking the subscription button. It's only going to take a moment, and then you can also hit the notification bell icon. So this way, every time we post a new content, you will be alerted. This brings us to the end of this part of this topic on motion, where we discussed the definition of motion, types of motion, and relative motion. So next up, we'll be looking at what causes motion, things like frictions and the like. So trust me, you don't want to miss it. So ensure that your notification is turned on so that you'll be notified as soon as the video comes online. Thank you for watching the video. I'll see you in the next one. Bye-bye.